Imagine a world where the brain is not just a static organ, but a dynamic one that can adapt, heal, and evolve. This phenomenon is known as neuroplasticity, and it plays a pivotal role in shaping our cognitive abilities and emotional resilience. Neuroplasticity refers to the brain's ability to reorganize itself by forming new neural connections throughout life. This means that our experiences can physically transform the structure of our brains, making it a living and adaptable organ. Scientists have discovered that this remarkable capacity can occur in response to learning, environmental changes, and even injury. One of the most compelling cases demonstrating neuroplasticity is that of a man named Jody Miller. In his mid-30s, Jody suffered a devastating stroke that left him unable to speak or move the right side of his body. Doctors warned his family that he might never recover. However, through intense rehabilitation and sheer determination, Jody began to regain his speech and mobility. His brain had rewired itself, creating new pathways that allowed him to perform tasks he once took for granted. Jody's story is not an isolated incident. Thousands of stroke survivors have shown remarkable recovery due to the brain's ability to adapt. This raises essential questions about how we can harness the power of neuroplasticity for healing and learning. Research has shown that engaging in activities that stimulate the brain, such as learning a new language or playing a musical instrument, can enhance neuroplasticity. Studies further reveal that meditation and mindfulness practices can strengthen neural connections while reducing stress and anxiety. These findings suggest that we have the potential not only to recover from injuries but to continuously improve our cognitive abilities. But as we delve deeper into the mysteries of neuroplasticity, we encounter a poignant cliffhanger. Just how far can we push the limits of our brains? The answers may lie in the realm of brain-computer interfaces, where scientists are beginning to explore the frontiers of human capability. From traumatic accidents to strokes, brain injuries can dramatically alter the lives of individuals and their families. Yet, astonishingly, the human brain has shown remarkable resilience in recovering from such traumas, showcasing its incredible capacity for regeneration. Consider the story of Dr. Michael Merzenich, a pioneering neuroscientist who dedicated his life to understanding brain injuries. In the 1980s, he embarked on a mission to study the effects of brain damage and the potential for recovery. His research unearthed profound insights into how the brain can heal itself, offering hope to thousands. Dr. Merzenich conducted a remarkable experiment with patients suffering from traumatic brain injuries. Through tailored cognitive exercises and training, he guided these individuals to regain lost functions. One striking case was that of Sarah, a young woman who suffered a severe head injury in a car crash. Doctors initially deemed her prognosis grim. However, through innovative rehabilitation techniques developed by Dr. Merzenich, she began to regain her speech and movement. She was eventually able to resume her life, proving that the brain's capacity for recovery is far greater than previously imagined. Scientific studies have shown that recovery from brain injuries is not just possible but can be accelerated through dedicated rehabilitation. A study published in the journal Neurorehabilitation and Neural Repair found that patients who engaged in intensive therapy saw remarkable improvement compared to those who did not. Another groundbreaking aspect of brain injuries is the phenomenon of spontaneous recovery, where individuals can regain function without any therapy. This illustrates the brain's inherent ability to heal itself, highlighting the complexities of recovery mechanisms that science is still unraveling. But what if the potential for recovery could extend beyond the natural limits? As we transition into the next chapter, we will explore the cutting-edge technology that is bridging the gap between machines and the brain, radically transforming not just recovery, but human capabilities as a whole. Imagine a world where thoughts can control machines, where the power of the mind transcends the boundaries of organic life. This is the extraordinary potential of brain-computer interfaces, BCIs, technology that allows direct communication between the brain and external devices. The journey into the realm of BCIs began with remarkable experiments by researchers like Professor Miguel Nicolis. In his groundbreaking work, he demonstrated that monkeys could control robotic arms using only their thoughts. Through sophisticated algorithms, the monkeys learned to manipulate the robotic limbs as if they were their own, opening a new frontier in neuroscience and robotics. The implications of BCIs extend far beyond laboratory experiments. For individuals paralyzed by spinal cord injuries, BCIs offer a flicker of hope. One groundbreaking success story features a man named Ian Burkhart, who, after a diving accident, lost all feeling and movement below his shoulders. In a pioneering study, researchers implanted a BCI that translated his thoughts into movements, enabling him to move a robotic arm and even feed himself. The technology is still in its infancy, but its potential applications are astounding. BCIs can restore mobility, enhance communication, and even assist in mental health treatment. Researchers are now exploring how BCIs could change the way we interact with computers, allowing users to control them just by thinking. However, with great power comes great responsibility. The advent of BCIs also raises ethical and philosophical questions about what it means to be human. As we expand our cognitive capabilities, we must grapple with the implications of merging biology with technology. As we ponder these profound dilemmas, the question remains, how will this technology shape our society? Our exploration into the next chapter will uncover the hidden layers of consciousness and how they intertwine with our everyday experiences. What exactly is consciousness? This question has puzzled philosophers, scientists, and thinkers for centuries. Consciousness is what makes us human, yet its nature remains an enigma. From self-awareness to perception, consciousness encompasses our thoughts, emotions, and experiences. Neuroscientists have long sought to unravel the mysteries of consciousness, and recent breakthroughs have shed light on its complexities. One significant study led by neuroscientist Anil Seth examined how the brain constructs our reality through sensory input and cognitive processes. Seth's research suggests that consciousness is not a singular entity but rather a spectrum of experiences ranging from simple awareness to profound self-reflection. This means that our conscious experience is shaped by our perceptions, memories, and even our expectations. In an extraordinary experiment, researchers used brain imaging to study patients in vegetative states. Surprisingly, some individuals demonstrated signs of awareness despite their inability to communicate. This raises ethical questions about our understanding of consciousness and how we define what it means to be alive. Moreover, have you ever wondered why we dream? Dreaming is an essential aspect of consciousness that has captivated humanity throughout history. Neuroscientific studies show that dreams play a vital role in processing emotions and memories, acting as a sort of nightly therapy. This intriguing connection brings us to the cliffhanger of our exploration. If consciousness is so malleable and intertwined with our experiences, what potential does it hold for our future? As we transition to our next chapter, we will delve into the astonishing impacts of dreams on our waking lives and what they reveal about our subconscious. Dreams have long fascinated humanity, transcending cultures and generations. But what purpose do they serve? Research suggests that dreams play a significant role in our emotional and psychological well-being. Through vivid narratives and surreal experiences, our subconscious minds seek to process unresolved feelings and life events. One compelling study conducted by researchers at Harvard University found that individuals who recorded and analyzed their dreams showed improved psychological health. Participants who engaged in dream journaling reported reduced anxiety and a greater understanding of their emotions. Moreover, dreams can serve as powerful tools for creativity and problem-solving. Famous figures like Salvador Dali and Thomas Edison derived inspiration from their dreams. Dali's iconic paintings often reflected dream imagery, while Edison famously stated that he would bring his problems to sleep, allowing his mind to work on them subconsciously. Dreams also reveal intriguing insights into our fears and aspirations. Have you ever woken up from a dream, feeling an unsettling emotion? Through rigorous research, psychologists have mapped common dream themes, linking them to our waking lives. Dreams about falling, chasing, or inadequacy often reflect our subconscious anxieties and stressors. This points to the notion that our dreams are not just random brain activity but meaningful narratives echoing our realities. As we ponder these revelations, we approach a profound question: if our dreams can shape our waking lives and emotions, what untapped potential resides within our subconscious? This question leads us seamlessly into our next chapter, where we will further explore the intersection of neuroscience and the subconscious mind, unveiling the hidden layers of our psyche. Memory is one of the most fascinating and complex functions of the human brain. But it isn't just one single process. Rather, it's a web of interconnected systems and structures that all play a role in how we remember. From the fleeting whispers of short-term memory to the enduring echoes of long-term memory, the brain operates with astonishing efficiency. The hippocampus, a small, seahorse-shaped structure nestled deep within the brain, is pivotal for forming new memories. Research shows that humans have the remarkable ability to create about 70 new memories each day. But what happens when this delicate system is disrupted? Consider the case of patient HM. After undergoing surgery to alleviate severe epilepsy, HM suffered from profound anterograde amnesia, unable to form new memories after the operation. His case has provided invaluable insights into memory consolidation processes, showing how critical the hippocampus is to our ability to learn and remember. But there's more than just the hippocampus involved. The brain houses distinct types of memory: procedural memory, which governs skills and actions, and declarative memory, which is about facts and events. A fascinating study by neuroscientist Elkanan Goldberg revealed how individuals can still excel at procedural tasks without being able to recall the specific experiences tied to these memories. For instance, the act of riding a bike can be learned without retaining any conscious memory of the lesson itself, a phenomenon that illustrates the complexity of our memory systems. The role of sleep in memory retention also cannot be understated. Research indicates that sleep solidifies our memories, with deep sleep being essential for the brain to process and store information effectively. This explains why students often feel the urge to cram before exams, yet those who ensure they sleep well retain significantly more information. Interestingly, sleep can even lead to unexpected insights. One study highlighted that participants who napped after learning new information displayed higher creativity in problem-solving tasks later on. Furthermore, there are nuances in memory retrieval, such as the concept of retrieval-induced forgetting. This counterintuitive phenomenon suggests that when we successfully recall certain memories, we inadvertently forget related ones. This is often observed during police interrogations, where focusing on specific details of an event can lead witnesses to misremember or overlook others. The implications of this are profound, as they touch upon the reliability of eyewitness testimonies. As we delve deeper into the caverns of the mind, it's clear that the systems supporting memory are intricate and multifaceted. Yet, just when we think we understand our memory systems, new research emerges that challenges our previous notions. For instance, studies on memory reconsolidation demonstrate that memories are not static. They can change every time we retrieve them, raising questions about the reliability of our recollections. So, what does this mean for our understanding of identity? If our memories are fluid and changeable, could it be that our sense of self is just as malleable? As we consider the depths of memory's mysteries, we come to realize that every recall is not merely a window into the past, but a complex interplay of the brain's architecture, influencing who we are today. As we move forward, let's explore how these memory systems can be both a blessing and a curse, leading us into Chapter 7, The Burden of Memory. Memory is both a gift and a burden. While it allows us to learn, grow, and connect with others, it can also manifest in ways that become overwhelming and traumatic. For individuals with PTSD, their memories of traumatic events can intrude uninvited, leaving them haunted by flashbacks and nightmares. It's a stark contrast to the benefits that memory provides. The brain processes memories through pathways that can become scarred or altered by trauma. The amygdala, an almond-shaped cluster of nuclei in the temporal lobe, is responsible for emotional processing and often becomes hyperactive in those suffering from PTSD. This hyperactivity can create a constant state of alertness, making it difficult for individuals to distinguish between safe and threatening environments. Studies reveal that approximately 8% of the population will experience PTSD at some point in their lives, a statistic that underscores the widespread effects of trauma. In stark contrast to trauma, there's the phenomenon of nostalgic memory, those warm, wistful recollections of the past that can ground us during turbulent times. Researchers like Dr. Konstantin Sedekides have shown that nostalgia can enhance self-esteem and foster social connectedness. Yet, while nostalgia can provide comfort, it can also lead people to yearn for times long gone, creating a bittersweet feeling that can be both soothing and painful. Additionally, the debate over the accuracy of repressed memories adds a layer of complexity. Are our memories reflections of reality, or are they susceptible to distortion? In court cases, individuals have unambiguously recalled past traumas, only to later question the veracity of these memories. This raises profound ethical concerns about how we approach trauma, memory, and justice. The implications of memory burdens extend into the realm of mental health treatments as well. Therapeutic techniques such as EMDR, eye movement desensitization and reprocessing, demonstrate how controlled exposure to traumatic memories can desensitize individuals and enable them to process their experiences more effectively. These therapies encourage patients to face their memories rather than suppress them, leading to profound changes in how memories are experienced. But what about our societal memories? Collective memory shapes cultures and communities. The way societies remember events, like wars, revolutions, or cultural milestones, affects their identity and future direction. Historical memory can be a force for healing or a catalyst for conflict, highlighting the power of memory not just at an individual level but on a grand scale. As we explore deeper into the human experience, the dual facets of memory, its ability to empower and burden, begins to come into focus. How we navigate our memories can shape our future, affecting not only our personal lives but our communities. Our next chapter will take us into uncharted waters, where the mind's resilience meets the mysteries of aging in Chapter 8, The Aging Brain. As we traverse the landscape of human development, we encounter the phenomenon of aging, a complex interplay of biology and experience that affects every aspect of our lives, including our brains. The aging brain is not merely a repository of memories. It undergoes significant changes that can enhance wisdom while simultaneously presenting challenges. By the age of 60, the brain begins to shrink, especially in the frontal lobe, which is responsible for decision-making and impulse control. Research from the American Academy of Neurology shows that about 40% of people experience cognitive decline as they age, yet this is not the whole story. Many older adults continue to exhibit high levels of creativity and problem-solving skills, attributed to a lifetime of accumulated knowledge and experiences often referred to as crystallized intelligence. Consider the story of Dr. Robert Yaffe, a 102-year-old neuroscientist who published groundbreaking research well into his 90s. His journey embodies the idea that aging doesn't necessarily equate to a decline in cognitive ability. In fact, many studies suggest that older adults excel in areas that require experience, such as emotional regulation and interpersonal skills. However, certain cognitive functions are affected more significantly by aging. Memory recall, especially short-term memory, can become impaired. This is due in part to the decline in neurogenesis, the process of creating new neurons, which is crucial for learning and adaptability. In young adults, neurogenesis occurs rapidly in the hippocampus, but this process slows with age, leading to the difficulty many older adults face in learning new information. Interestingly, regular mental and physical activity has been shown to promote adult neurogenesis, suggesting that a proactive approach to aging can lead to better cognitive outcomes. Studies have demonstrated that engaging in puzzles, reading, and even socializing can stave off some cognitive decline. Additionally, exercise increases blood flow to the brain, offering further protection against cognitive degeneration. As we contemplate the journey of the aging brain, it's also essential to address neurodegenerative diseases such as Alzheimer's. This complex condition currently affects nearly 6 million Americans, and projections indicate that this number could reach 14 million by 2050. Scientists are racing against time to better understand the mechanisms behind Alzheimer's, with research revealing a potential link between the buildup of amyloid plaques and tau proteins and the onset of the disease. The need for effective treatment options has never been more urgent. The interplay of biological processes and lifestyle choices showcases the resilience of the human brain, yet also highlights the challenges we must face as we grow older. As we conclude our examination of the aging brain, we must remember that it is not the years that define us, but how we choose to engage with the world around us. How we adapt and embrace change speaks volumes about our human experience. With this in mind, let's transition into Chapter 9, The Future of Brain Science. As we gaze into the horizon of neuroscience, we find ourselves at the precipice of astonishing breakthroughs that could redefine our understanding of the brain. With advancements in technology, from brain imaging to artificial intelligence, we are beginning to unlock the mind's most profound mysteries and, perhaps, its greatest potentials. Innovative technologies like functional MRI, fMRI, and PET scans have transformed neuroscience by allowing us to visualize brain activity in real time. These tools have enabled scientists to observe how different areas of the brain communicate and work together, revealing the intricacies of our neural networks. As neuroscientist David Eagleman famously said, "The brain is like a time machine. It allows you to travel into the past and the future." This new understanding paves the way for revolutionary treatments for mental health disorders, cognitive decline, and even brain injuries. Moreover, neural interfaces are beginning to blur the lines between human cognition and machine intelligence. Companies like Neuralink are exploring ways to connect our brains directly to computers, which could dramatically alter our interactions with technology, enhance learning, and even offer solutions for those with neurological disorders. Imagine a future where individuals with paralysis can control devices with their thoughts, or where our cognitive capabilities can be augmented with artificial intelligence. But with great power comes great responsibility. As we tread further into these uncharted territories, ethical considerations loom large. Questions arise about consent, privacy, and the implications of potentially manipulating memories or augmenting cognitive functions. The dilemmas posed by advancements in brain science challenge us to reflect on what it means to be human. This is especially true when we examine the realm of artificial intelligence. As machines learn and evolve, the fear of losing our humanity becomes palpable. What defines human consciousness? Are machines capable of experiencing emotions, or will they always be mere imitations of the human experience? These questions are not just speculative musings, they are central to our understanding of society in the coming decades. Ultimately, the journey of brain science is not merely about discovery, it's about understanding ourselves. Each breakthrough brings new insights and challenges us to think critically about how we use that knowledge. The path forward is illuminated by both opportunities and risks, compelling us to create frameworks that prioritize ethics and humanity in the age of cognitive advancement. As we conclude this exploration of the human brain and its myriad mysteries, we are left with one profound truth: the human mind is a labyrinth, and within its depths lie not just answers, but more questions. The state of our understanding today sets the stage for tomorrow's exploration, reminding us that the journey of knowledge is never-ending, and that every mystery unveiled leads us to new adventures in science and self-discovery. We may not have all the answers now, but with every inquiry, we pave the way for generations to come. Thank you for joining us on this remarkable journey through the mind. In the quest to understand the human brain, we find ourselves standing at the threshold of the mind's final frontier, a space that stretches beyond biology and into the realms of consciousness, creativity, and the very essence of existence. Humanity has always sought to decipher the mysteries of consciousness, to answer the age-old question, what does it mean to be aware? Philosophers have pondered this for centuries, but with advancements in neuroscience, we are closer than ever to unraveling these profound questions. Recent studies suggest that consciousness may arise not from any one area of the brain, but rather from the dynamic interactions among various networks within this intricate organ. The default mode network, for example, activates during introspective thought, daydreaming, and planning, quickly intertwining with other networks to create a rich tapestry of cognitive experience. Researchers like Dr. Anil Seth propose a model of consciousness that aligns perception with bodily awareness, emphasizing the interplay between the brain, the body, and the world around us. This notion of interconnectedness extends to our creativity, often seen as the ultimate expression of human consciousness. The ability to innovate, to think divergently, and to imagine is not just a byproduct of neural connections. It reflects the manifestation of our thoughts and feelings as they intermingle with external influences. Through studies of divergent thinking and brain activity, researchers have found that creative individuals often show unique neural patterns that differ from those of less creative peers. Yet, as we venture deeper into the realm of consciousness and creativity, ethical implications emerge. If we can stimulate creativity or access heightened states of awareness through neuroenhancement, what does this mean for the authenticity of our thoughts and artistic expressions? The infusion of technology in nurturing creativity raises questions about the very nature of artistic integrity and the ownership of ideas. Even beyond creativity, the exploration of altered states of consciousness, through meditation, psychedelics, or sensory deprivation, reveals the potential of the mind to transcend ordinary experience and access deeper insights. Research into psychedelics has demonstrated how substances like psilocybin can break down the rigid structures of the ego, promoting feelings of interconnectedness and profound insight. These findings present exciting possibilities for therapeutic applications in areas such as anxiety, depression, and substance abuse. As we stand on the brink of these discoveries, the promise of unlocking the mind's final frontier brings us face to face with profound ethical dilemmas. How do we navigate the complexities of consciousness expansion and access to mental states that, until now, have been regarded as deeply personal? The path ahead requires a delicate balance between exploration and respect for individual autonomy. In closing, our exploration into the mysteries of the human brain and mind has illuminated the beauty of our complexity, our capability for growth, and the wonders yet to be discovered. Each chapter of our understanding brings with it new questions, adventures, and opportunities. As we continue to seek answers in the labyrinth of consciousness, let us remain curious and compassionate, embracing the intricacies of our existence. The journey of understanding the human brain is a shared odyssey, and together, we can forge pathways into the unknown, illuminating the darkest corners of our minds and expanding the horizons of human experience. The brain is an intricate orchestra, with neurotransmitters serving as its musicians. These chemical messengers play crucial roles in the way we think, feel, and behave. Imagine a tightly knit symphony where each note contributes to a larger composition. This chapter explores the various neurotransmitters that influence our emotions and behaviors, ranging from the cheerful boosts of dopamine to the calming effects of serotonin. In the 1950s, a pioneering researcher named Arvid Carlsson discovered the role dopamine plays in movement and reward. His work laid the groundwork for understanding Parkinson's disease, a condition characterized by the death of dopamine-producing neurons. Patients often experience tremors and stiffness, dramatically altering their ability to perform everyday tasks. But dopamine does not only impact physical movement, it's linked to our motivations and the pleasure we derive from experiences. Contrast this with serotonin, another essential neurotransmitter. Often dubbed the happy hormone, serotonin regulates mood, anxiety, and happiness. In the late 1980s, researchers found that drugs like SSRIs, selectively targeting serotonin, could alleviate depression in many individuals. Yet, the story doesn't end here. Recent studies have shown that serotonin also plays a role in gut health, revealing a fascinating link between our brain and our microbiome. As we dive deeper, we discover that neurotransmitters interact in complex ways. Glutamate, for instance, is excitatory and plays a pivotal role in learning and memory. But an excess of glutamate can lead to neural damage, linked to conditions such as Alzheimer's disease. This intricate balance is what makes understanding neurotransmitters both fascinating and critical for future brain science. In hospitals worldwide, scientists and doctors are analyzing brain chemicals to develop new treatments for mental health disorders, highlighting the importance of understanding this musical composition. Could it be that the right balance of neurotransmitters holds the key to mental wellness? The next chapter will take us on another incredible journey, the brain's connection to technology, where we explore the possibilities of merging minds with machines. What does the future hold for humanity in this brave new world? Stay tuned. Creativity is often viewed as an ethereal quality, an elusive spark that ignites artistic genius or groundbreaking ideas. But what if we could decode the mysteries behind creativity? This chapter delves into the neuroscience of creativity, exploring how different brain regions collaborate to unleash innovative thoughts. In the early 2000s, a landmark study involving functional MRI scans revealed fascinating insights into the creative process. Researchers found that when individuals engage in creative tasks, a network of brain areas, including the default mode network, becomes highly active. This default mode network is associated with daydreaming, recalling memories, and envisioning future scenarios. It seems that creativity flourishes when we allow our minds to wander. Artists often report that their best ideas come during times of rest or unstructured thought. But this doesn't mean that creativity is merely a byproduct of relaxation. The right cortex, the area responsible for focused thinking, also plays a crucial role during the creative process. Consider the case of the famous inventor Thomas Edison, who famously said, "Genius is 1% inspiration and 99% perspiration." Edison's relentless work ethic underscores the importance of discipline in creativity. His method of trial and error exemplifies how hard work combines with creative thinking to produce groundbreaking inventions, giving birth to technologies that changed the world. Moreover, creativity isn't limited to the arts, it extends into science, where innovation thrives on questioning the status quo. For example, Marie Curie's groundbreaking discoveries in radioactivity were born from both rigorous scientific inquiry and imaginative thinking. The intersection of these two realms continues to yield remarkable discoveries. As we consider the era of creativity, one must ask, can we train our brains to be more creative? Studies have shown that practices like mindfulness and brainstorming can enhance creative thinking. Imagine tapping into this potential within your mind. The next chapter will illuminate the mysteries of consciousness, a topic that remains one of the most profound puzzles in neuroscience. What is consciousness, and where does it originate? Stay tuned as we explore this mysterious landscape of the human experience. Have you ever experienced the profound impact of stress on your body, or the uplifting effects of positive thinking? This chapter delves into the fascinating interplay between the brain and body, a connection that shapes our reality in ways we are just beginning to understand. The concept of the mind-body connection has roots in ancient Eastern philosophies, but modern neuroscience provides evidence of this link. One key aspect is the role of the autonomic nervous system, which regulates bodily functions such as heart rate and digestion. Research shows that our thoughts can influence this system. For instance, during stressful situations, our brain triggers a fight-or-flight response, releasing hormones like adrenaline and cortisol. Chronic stress is linked to various health issues, including heart disease and obesity. Consider the case of Dr. Herbert Benson, a pioneer in mind-body medicine. In the 1970s, he conducted research demonstrating how relaxation techniques could negate the adverse effects of stress, promoting healing in patients. However, the connection goes both ways. Just as our thoughts can affect our body, physical health can influence mental well-being. Exercise, for example, releases endorphins, which improve mood and reduce feelings of anxiety. In a fascinating study published in the Journal of Sport and Exercise Psychology, researchers found that students who engaged in regular physical activity reported higher levels of self-esteem and lower levels of anxiety compared to their sedentary peers. This chapter also considers the implications for chronic pain management. The brain's perception of pain can be altered through cognitive behavioral interventions, showing that our thoughts and beliefs about pain can significantly affect our experience. For instance, the placebo effect is a powerful demonstration of this phenomenon. Patients often report symptom relief when they believe they are receiving treatment, even if it's just a sugar pill. As we move forward, the next chapter invites us to explore the future of brain science and the potential ramifications of human intellect. How far can we push the boundaries of what it means to be human in a world of endless possibilities? Stay tuned. The human brain is a complex organ, weaving together thoughts, emotions, and behaviors. But what happens when this delicate balance is disrupted? As we explore the dark side of the brain, we delve into the world of mental illness, a realm filled with agony, stigma, and a search for understanding. From anxiety disorders to schizophrenia, the spectrum of mental health issues affects millions worldwide, casting shadows on their lives and those of their loved ones. Consider the case of John, a once vibrant artist whose passion for life was extinguished by depression. It was not just a fleeting sadness but a persistent battle against an unyielding darkness that clouded his mind. Statistics show that nearly 1 in 5 adults in the U.S. experiences mental illness in a given year. That's over 50 million individuals. The story of mental illness begins in the very structure of the brain. Neurotransmitters, the brain's chemical messengers, play a crucial role in regulating our mood and behavior. For instance, serotonin is often dubbed the feel-good neurotransmitter. However, in individuals suffering from depression, the levels of serotonin can become imbalanced, leading to profound sadness and despair. Scientists have conducted extensive studies to map the brain regions associated with various mental health disorders. The prefrontal cortex, responsible for decision-making and impulse control, is often underactive in those with conditions like ADHD. Meanwhile, the amygdala, the brain's emotion center, shows heightened activity in anxiety disorders. But what about the impact of these disorders on everyday life? The stigma surrounding mental illness often compounds the problem, leading individuals to suffer in silence. According to the National Alliance on Mental Illness, nearly 60% of adults with mental illnesses did not receive treatment in the previous year. In recent years, however, there has been a shift in understanding and treatment. Innovative therapies such as cognitive behavioral therapy, CBT, and mindfulness practices have shown promise in helping individuals regain control over their lives. Additionally, the development of medications targeting specific neurotransmitter systems has provided new hope. John's journey illustrates the power of community support and therapy in overcoming mental health challenges. Through counseling and medication, he learned to rebuild his life, expressing his emotions through art and connecting with others who understood his struggles. Their shared experiences created a safe space, allowing for healing and understanding. In conclusion, the exploration of mental illness within the realm of human brain mysteries reveals not just the intricacies of neurobiology but also the resilience of the human spirit. The journey from darkness to light is often long, yet it underscores an essential truth: there is power in understanding, compassion, and community. As we continue to unravel the brain's complexities, the hope is that we can dismantle the stigma and foster a society where mental health is prioritized and celebrated. What lies ahead for mental health treatment? Can technology like AI and neuroimaging further revolutionize how we comprehend and treat these disorders? What if everything you perceive isn't an accurate reflection of reality? The human brain intricately shapes our understanding of the world, influencing how we see, hear, and even think. This chapter dives deep into the concept of perception, a complex interplay between sensory information and cognitive interpretation. Imagine standing in a dark room. Your eyes struggle to adjust, yet your mind begins to fill in the blanks, shadows twist into shapes and sounds morph into whispers. This is an example of how the brain constructs reality based on incomplete information. Through a fascinating blend of psychology and neuroscience, researchers have uncovered that our perceptions are not mere reflections. They are greatly influenced by past experiences, expectations, and even emotions. Consider the famous rubber hand illusion. In this experiment, participants watch a rubber hand being stroked in sync with their own hidden hand. The brain quickly takes ownership of the rubber hand, showcasing its plasticity and the profound effect of visual stimuli on body perception. Psychologists have long studied the nuances of perception. The Gestalt principles of perception illustrate how we instinctively seek patterns and organization in our environment. For example, when looking at a series of dots, our brain tends to group them into shapes, creating a coherent image instead of a random collection. Even our memories influence our perception of current experiences. A person who has enjoyed a specific food might perceive its taste as better than someone who had a negative experience with it. This phenomenon underscores the subjective nature of reality. Neuroscientific research indicates that the hippocampus plays a crucial role in memory processing, thus highlighting the intertwined relationship between memory and perception. Moreover, our perception can be altered by the brain's complex responses to expectation. The placebo effect reflects this beautifully. When patients believe they are receiving treatment, many report feeling better, even if no active intervention occurs. This powerful interaction between mind and body demonstrates the capacity of belief to shape our physical reality. The implications of understanding perception are vast, extending to fields like marketing, education, and even technology. In advertising, companies leverage psychological triggers to influence consumer decisions, knowing that how something is presented can dramatically affect how it's perceived. Ultimately, the exploration of perception reveals that reality is far more intricate than a simple reflection of the environment. The brain's ability to mold our understanding of the world leads us to question how much of our perception is truly accurate. What unknown possibilities exist if we can learn to manipulate or better understand this process? The pursuit of these answers may unlock profound secrets about the human experience and the nature of consciousness itself. As we unravel the mysteries of perception, we find hints at a deeper truth, that our reality is as much a product of our brains as it is of the world around us. Did you know that a significant portion of your brain's activity occurs below the level of conscious awareness? Welcome to the mysterious realm of the unconscious mind, where thoughts, feelings, and memories reside without our active control. Freud famously posited that the unconscious houses our repressed desires, but modern neuroscience has evolved this concept. Today, we understand that the unconscious mind plays a pivotal role in decision-making, influencing our behavior in ways that can often seem unfathomable. Take the case of someone choosing a snack. Most people believe their choice is based on rational thinking. However, studies reveal that subconscious cues, such as the color of the packaging or prior experiences with the brand, heavily influence their decision. This unconscious processing allows the brain to make quick choices based on learned patterns, thus conserving mental energy. One prominent example of this is the phenomenon known as priming. When exposed to certain stimuli, individuals react differently based on subconscious associations. For instance, studies show that when individuals see words related to old age, they tend to walk more slowly afterward, highlighting the brain's internal associations. Our unconscious also harbors implicit biases, which can affect our interactions, opinions, and decisions without us even realizing it. These biases develop from social conditioning and personal experiences, often leading to unintended prejudice and judgment. Furthermore, some researchers suggest that the unconscious mind is the repository of creativity. Many artists and thinkers report that their best ideas emerge from a state of mind disconnected from rational thinking. This aha moment often happens just when one is not actively trying to solve a problem. The implications of harnessing the power of the unconscious are vast. Techniques like visualization and meditation aim to tap into this deeper level of awareness, promoting personal growth and emotional healing. Mindfulness practices help individuals recognize their subconscious patterns, allowing for transformation and insight. In closing, the exploration of the unconscious mind reveals that much of our behavior and thought originates from a realm beyond our immediate awareness. By becoming more attuned to this part of ourselves, we can learn to navigate life with greater insight, creativity, and emotional balance. What other mysteries lay within the depths of the unconscious? How can we further unlock its secrets to enrich our lives and understanding of the human experience? As we journey through time, the evolution of the human brain stands as a testament to our species' adaptability and ingenuity. The human brain, a 3-pound mass of gray matter, is not merely an organ, it is the very essence of what it means to be human. To understand the depth of its mysteries, we must first look back to our ancient ancestors. The earliest forms of human-like species, known as hominins, walked the earth over 6 million years ago. These creatures had brains significantly smaller than our own, approximately 1/3 the size, yet, they laid the groundwork for the remarkable cognitive evolution that would follow. Through natural selection, brain size began to increase significantly. By the time Homo habilis emerged around 2.4 million years ago, we see the first clear evidence of a larger brain, indicative of advanced tool-making skills and social behaviors. Imagine a world where the ability to craft tools was key to survival. These early humans began to forge their destinies using both their hands and their minds, hinting at a burgeoning capacity for complex thought. As evolution marched forward, the brain continued to grow, particularly in the frontal lobe area, associated with problem-solving and planning. The transition to Homo erectus marked a pivotal moment. This is the species that began to migrate from Africa, spreading across the globe. Each new environment posed challenges that required innovative solutions. Neuroscientists have found that as our ancestors faced diverse challenges, their brain structures adapted. For instance, studies of modern humans demonstrate that the size of specific brain areas correlates with the complexity of the societies individuals belong to, suggesting a direct link between environmental demands and brain evolution. Fast forward to the Upper Paleolithic period, roughly 40,000 years ago. where we see a significant leap in creativity and artistic expression. Cave paintings, intricate jewelry, and early music suggest the emergence of symbolic thinking, which is a hallmark of modern human cognition. This leap wasn't merely aesthetic. It indicated that the human brain had developed complex systems for communication and social bonding. The innovation did not stop there. With the dawn of agriculture around 10,000 years ago, our social structures became even more complex. Villages transformed into cities, leading to the development of a new set of neurological demands. Social hierarchies, economic systems, and written language began to shape the human experience. But why does this matter? Understanding the evolutionary journey of the human brain not only unveils the origins of creativity and intelligence but also sheds light on present-day societal dynamics, including how we interact with technology and each other. This ongoing evolution prompts us to ask whether we are still adapting to the challenges of modern life, and what that means for our cognitive abilities and our future. As we explore the remaining revelations of our brain's evolution, we realize that the journey of our species is far from over. What could be next for the brain as we dive deeper into the digital age? Therefore, we stand at a profound intersection, an opportunity to shape our own evolutionary path. What will we do with this incredible brain? Our exploration continues, uncovering more layers of the mysteries held within. Have you ever experienced a moment so vivid it felt as though time had stopped? Emotion and memory are inextricably linked, shaping the narrative of our lives. Research shows that emotional experiences can enhance our ability to remember details. It is fascinating how the amygdala, the brain's emotional center, works with the hippocampus, responsible for memory formation. In 1986, a remarkable study by James McGaugh revealed that patients suffering from amnesia could remember emotionally charged events with greater clarity than neutral ones. This phenomenon can be illustrated through a case study of a woman named Jennifer who witnessed a traumatic car accident. Despite having significant memory impairments from a stroke, she vividly recalled the emotional details of the incident, what she wore, the sound of the crash, and the people involved. Jennifer's story exemplifies how emotional weight can etch memories into the fabric of our minds, even when other memories fade away. On the flip side, the brain's emotional wiring can also lead to memory distortions. For instance, during stressful situations, our bodies release stress hormones like cortisol, which can both enhance and impair our memory formation. Another real-life example can be traced back to the 9/11 terrorist attacks. Many who were present recall their experiences with unsettling clarity, yet researchers found that not all details were accurate. The emotional intensity of the event skewed their memories, leading some to believe they had witnessed events that never occurred. This interplay poses intriguing questions. How do emotions shape our perceptions of reality? How do they influence our beliefs and behaviors? The neuroscience behind this connection reveals the complexity of our emotional landscape, which is constantly in flux. The implications are far-reaching. Emotionally charged memories often inform our decision-making processes. Consider a study published in the journal Cognition and Emotion that outlines how people are swayed by emotionally vivid memories when judging future risks. Imagine trying to cross a busy street. An emotional memory of a near-miss accident might cause someone to hesitate far longer than a neutral recollection of past crossings. This phenomenon is not just an academic curiosity, it's a survival mechanism that stems from our ancestors' experiences. Moreover, the growing field of affective neuroscience is uncovering how deep emotional experiences can be harnessed in therapeutic settings to help individuals process trauma. Techniques like eye movement desensitization and reprocessing, or EMDR, leverage emotional memory to heal psychological wounds. As we continue to unravel the mysteries of how our brains handle emotion and memory, we are also learning to navigate the complexities of our own mental architectures. What does this mean for our understanding of happiness, trauma, and the human experience. With this knowledge, we can begin to take control of our emotional narratives, shaping our memories consciously rather than being mere passengers on this journey. The relationship between emotion and memory continues to be a profound exploration, guiding us toward understanding the depths of what it means to be human. Humans are inherently social beings, a trait that is deeply rooted in our neurological makeup. From early childhood, we form connections that shape our identities and worldviews. Yet, what lies behind the brain's social networks? A landmark study conducted by neurobiologists at Harvard revealed that social interaction activates the brain's reward system, particularly the release of dopamine. This chemical cocktail reinforces positive feelings and encourages us to seek out connections with others. But these networks aren't merely about dopamine. The brain's social processing centers, located in the prefrontal cortex, allow us to navigate complex social dynamics, understand nuanced emotions, and empathize with others. For instance, the famous mirror neuron system in our brain plays a crucial role in how we understand and imitate others' actions and emotions. Discovered through studies with macaque monkeys, these neurons fire both when an action is performed and when it is merely observed. This mechanism is fundamental to learning. Imagine a child watching a parent tie their shoes. As they observe, their mirror neurons activate, effectively allowing them to internalize the action. This is how social learning happens, and it's vital for our survival and functioning in society. However, social connections can also have darker implications. Research has identified that loneliness can trigger similar brain responses as physical pain, highlighting how critical connection is to our well-being. The brain, when deprived of social interaction, may experience elevated levels of stress and anxiety. In today's digital age, social media platforms have transformed how we connect. While they allow for unprecedented connections, they can also contribute to feelings of isolation. A study from the University of Pennsylvania found that higher social media usage correlates with increased feelings of loneliness and depression among young adults. Amidst the complexities of social networks, it's essential to recognize how they influence our behavior and decision-making. A phenomenon known as social proof demonstrates how individuals often look to others when making choices. For example, when entering a restaurant, if you see a crowd, you're more likely to believe the food is good based solely on the group's presence. Understanding the brain's social networks offers invaluable insights into not only human behavior but also how we can foster positive connections. Psychologists advocate for practices that enhance our social well-being, such as forming meaningful relationships and cultivating empathy. Ultimately, the exploration of our brain's social networks leads us to a critical question. How can we leverage our neurological understanding to create more fulfilling interactions in our daily lives? As we continue to delve into these connections, we are not only parsing the biological underpinnings of social behavior but also striving for a more compassionate existence. As we age, it is commonly believed that our brain cells, or neurons, are irreplaceable. But what if I told you that recent research is uncovering a remarkable phenomenon known as neurogenesis? This is the process of generating new neurons, primarily occurring in the hippocampus, a region intimately involved in memory and learning. For decades, scientists were convinced that neurogenesis was limited to early development, but breakthroughs in neuroscience have illuminated the potential for regeneration even in adulthood. Researchers have identified several factors that can enhance or inhibit neurogenesis. Exercise is perhaps the most well-documented stimulant. A study conducted at the University of Massachusetts showed that running can increase the production of brain-derived neurotrophic factor, or BDNF, a protein crucial for the growth of new neurons. Not only does physical activity promote a healthier body, but it also helps keep our brains youthful and adaptable. Interestingly, the environment plays a significant role in neurogenesis as well. A stimulating environment filled with challenges and social interactions can foster the birth of new neurons. In contrast, chronic stress or depression is known to inhibit neurogenesis, leading to cognitive decline. This connection highlights the interplay between our mental state and biological processes, revealing how stress management techniques such as mindfulness can contribute to neuroplastic health. Moreover, neurogenesis is not merely an isolated process. It is part of a larger ecosystem within the brain. This ecosystem includes glial cells, which support and nourish neurons, and neurotransmitters that relay messages among them. Therefore, a holistic approach that considers lifestyle factors, like nutrition, exercise, and mental health, holds promise for enhancing both neurogenesis and cognitive functions. Imagine having the ability to not only slow down age-related cognitive decline but also improve your memory through conscious lifestyle choices. This is not a distant dream. It is becoming increasingly evident as researchers delve deeper into neurogenesis. As we explore the implications of neurogenesis, one intriguing study conducted by neuroscientists at the University of California showed that even our thoughts can influence the process. In their experiment, they found that subjects who engaged in cognitive challenges produced more new neurons compared